So today we're starting section 4.5. Your entire packet that I just gave you covers one overarching concept, and that is inequalities. You're going to see the word inequality in all 4 of the lessons that we teach in this unit. All right, so what it means to look at an inequality is there's not just one answer. We're looking for basically a cutoff value to tell us what answers would make the inequality true. All right, so today we're doing addition and subtraction. And good news, we solve inequalities the same way that we solve equations. So we use inverse operations to solve. This is important. We'll talk more about this in a couple slides from now, but we always need to read the variable first in our solution, okay? So sometimes the actual inequality symbol can look confusing when we're not reading the variable first, all right? And then, of course, we're going to graph our solutions, which we learned how to do that in 4.4. You guys remember that? Open dot, close dot. Which way is my arrow going? So we're going to solve these inequalities, and then we're going to graph our solution. All right, so in example 1, I have x minus 5 is less than negative 3. So I need to figure out a way to get x by itself, still on one side of the equation. How could I cancel out negative 5?
Plus 5.
Plus 5 to both sides. Plus 5 to both sides. Remember that big equal sign underneath, okay? And now I bring down my x is less than, what's negative 3 plus 5? 2. So now I have the number that starts my graph. Remember, my solution is the number that starts my graph. So my middle number is my solution. And now I need 1 unit less and 1 unit more. All right, so what's 1 unit less?
1.
1, and what's 1 unit more?
3.
3. And would that be an open dot or a closed dot?
Open.
Open. And would my arrow go left or right?
Left.
To the left. All right, and what that means for my arrow to go left is, and guys, I'm going to ask you this, all right? This could definitely show up on a quiz or a test. What does the solution mean? It means that any number less than 2 will make my original inequality true. So you can plug in, with an equation when I checked, I'm plugging in only one number. You can give me, could we come up with a couple examples of numbers less than 2? Yeah, absolutely. 1. What's another number less than 2? 0. And we could keep going, right?
Yeah.
Okay, so you could just choose one of them, like 0, for example. What's 0 minus 5?
5.
No, what's 0 minus 5?
Oh. Negative.
Yep, negative 5. Is it true that negative 5 is less than negative 3?
Yes.
Yes. So what I'm showing you here, now this part is not necessarily part of what you have to write in your answer, but I need you to understand what we're doing here, guys. We're saying that any number less than 2, and again, that's a lot of different numbers, when I plug it in, will make this inequality true. All right, do you see that?
Yes.
And then we graph the cutoff on our number line. For example, if I plugged in a 2, which I'm saying is not a part of my solution, it's not true when I plug it back in, okay? We box in x is less than 2 as our answer, but then we have our graph of our solution also. So on a quiz, it would be 3 points for an answer, 2 points for a graph. If you get the answer wrong, it's minus 5 because your graph is wrong also. Okay, but at the off chance that you got the answer right, but then you missed your graph, then you would lose 2 points. Okay, so that's how that would be graded. All right, so the second one, I still solve the same way. I need to do what to both sides to solve for B?
Add 3.8.
Add 3.8. So here we see decimal values, but that's okay. I'm just going to graph it a little different on the number line. B is less than or equal to 5.5. And on the number line, I just need to make sure that my solution is the middle value, 5.5. And as long as you choose a number less than 5.5 and greater than 5.5, we are okay. Now, here's what I don't want to see. Don't put negative 50 over here and positive 30 over here. Okay, don't do that. All right, I would like the values that you choose to be the same distance away from 5.5. For example, just go down a half, 5. Go up a half, 6. Go down a whole, 4.5, and up a whole, 6.5. You see what I'm saying?
Yes.
So I'm not going to take off points if you choose different numbers. But if you put negative 35 over here and then positive 6, you're probably going to lose a point for that. Does that make sense?
Yes.
Okay. All right, so open dot or closed dot.
Closed.
What are we saying about our solution when it's a closed dot? What are we saying about our solution, Matthew?
That can be the answer or number directly below it.
Yes, you're exactly right. That 5.5 is a part of this answer. That if I plug in 5.5, it will make the inequality true. 5.5 minus 3.8 is equal to, which is the bar, 1.7. And that all my other solutions have to go which way, left or right?
Left.
To the left, less than. Okay? So all my other solutions must be less than. Okay, so I draw my arrow to the left. Meaning if I plug in any number less than 5.5, it will make that inequality true. All right, do you see what we're doing? We're identifying the solutions. Is there only one solution? No, there's honestly an infinite number of solutions. Okay? All right, let's look at, I think you have a little timeout here. Let's just go ahead and solve this real quick. We're going to think, pair together, and share our answers. We're going to take just about 2 minutes to do this problem. All right, class, what did you do to both sides to solve? Yep, add 6 to both sides. And what is negative 7 plus 6?
Negative 1.
Negative 1. Is it going to be an open dot or a closed dot? Open and arrow going to the right. Does your answer match that?
Yes.
Okay, awesome. All right, now in example 2, we're just looking at just some different scenarios here with these inequalities. What do you notice about the first inequality that might be a little different? What do you notice, Aaliyah? Yes, the x is on the other side. So you might look at this and think that that's a less than sign. How many of you would say, yeah, that looks like a less than sign, right? But it's not. It's not. And that's where it can get tricky. Because what we're saying is the combination of x plus 14 actually has to be what?
Bigger.
Greater, yes. Okay, so because of this possible confusion, what I'm going to encourage you to do is actually to reverse the order here. So we see the x plus 14. If you see this on your homework, guys, instead of writing this as the original problem, go ahead and switch it on your paper when you're copying the problems from the book. X plus 14. But here's the key. Here's the catch. Make sure that the inequality is still open towards the x when you switch it. All right? So you see how it's open towards the x? So when I rewrite it, it needs to stay open towards that side. Okay? Otherwise, you're going to get the answer wrong. Okay? So what I've done now, instead of, has anybody ever tried to read a book right to left? Like literally you're reading the lines backwards? Does it make any sense? Okay, so what we're asking you to do here is to read an inequality backwards, and that can get confusing. So instead of asking you to do that, we're going to rewrite it so we're reading it, forwards, frontwards, however you want to say it. Okay, and now it's a pretty simple step, right, to solve. What do I do to both sides? Just minus 14. Okay, and then x is greater than or equal to negative 1. All right, and now go ahead and graph your solutions. So we go negative 1, negative 2, and 0. Open or close dot? closed dot. And which way does my arrow go? It goes to the right. And when you write it frontwards or forwards, the greater majority of the time, you will get the arrow in the correct direction. All right, so going back to the original, this kind of looked like a less than sign, but it wasn't. So if I hadn't have rewritten it, I might have drawn the arrow in the wrong direction. Okay? All right, what do you notice is different about the next one?
It's fractions.
It's fractions, okay? But I am not using the reciprocal here. All right, so that is a mistake that I saw kind of popping up on your test yesterday. As I saw, you immediately see a fraction and you think, oh, I need the reciprocal. But in this case, what operation is connected to my fraction? Addition. So when it's addition, how am I going to get 3/4 to cancel? Yes, I need to minus it to the other side and minus 3/4. Okay, am I ready to subtract these?
No.
No, what do I need? Yep, I need that LCD. Okay, guys, I am not going to stress over you showing this work. I would hope that we could kind of mental math come up with our LCD here. Okay, and I'm totally fine with that. X is greater than, even if you wanted to change it up here, 22 over 4. What's 22 minus 3? 19 over 4. Now, this is definitely a scenario. Okay, if I see 19 over 4, that might be kind of hard to put on a number line, but I could change it to a mixed number, and that would make it easier to see how these numbers need to fall in the number line. 4 and 3/4, that's a lot more clear to me. All right, and as long as my number line starts with that value, I don't care what other values you choose. Again, it needs to be the same distance away. Okay, so don't choose just crazy numbers. Now, for 3/4, is there a decimal value that's equivalent to that? 0.75. If you use that decimal value, that's fine too. Okay, so honestly, guys, I would just round down to the next whole number. All right, and you could even round up to the next whole number. You say, well, Miss Kinder, this isn't necessarily the same distance apart. That's okay. All right, you're still showing, 1 unit above, 1 unit below. Would it be an open dot or a closed dot?
Open.
It's an open dot. And which way would my arrow go?
To the right.
To the right. Why does my arrow go to the right? Or better yet, what am I saying about the acceptable solutions by the way that I graphed my answer, Colin? What's they? Yes, what does X stand for?
X is the other number on the line.
Hallie, can you add to that?
It's like the number represented that's going to be greater than.
Okay. Yeah. It's the value that will make it true. It's the value that I can plug in to the original inequality, and it makes the inequality true. You guys remember you had that on your test yesterday where it said, plug it in and tell me if it makes it true? So I'm coming up with that cutoff number, and then all the numbers, in this case, greater than 4 3/4, when I plug in any number greater than 4 3/4, it makes the inequality true. Is that kind of, is that sinking in with you guys? Are you understanding that?
Yes.
All right, that's real important. Because, all right, I have, especially my honors students, they'll come to me and they'll say, Ms. Kinder, I can do this extremely difficult problem. I can do every step, but I have no clue why. Has anybody ever thought that? Like, I literally have no clue. I just know I came up with this answer, and I'm looking at it thinking, I have failed you because you don't understand why. So are you understanding a little bit of the why? All right, the ones who are laughing, yes, they can totally relate. Okay, and that's okay. I've been there too. All right. Okay, go ahead and do this think, pair, share problem real quick. Okay, subtract 3 from both sides. What's -1 minus 3? -4 goes in the middle. -5. I know this is a little sloppy. We're kind of in a hurry. Okay, closed dot and arrow going to the left. All right, who got it right? Who got it right? Great job. Great job. Okay, so now here's a challenge question. You say, Ms. Kinder, I'm never going to see this again, right? And I'm going to say, oh no, you're definitely going to see it again. I love problems like this. And you will love them too once you understand a little bit better. On the test question yesterday, I would say I definitely had some misses on this. So are you okay if I give you the first example? And then maybe you can come up with another one. I need an inequality that when I graph the solution, my graph would look like this. Okay, and because my lesson today is addition and subtraction, I'll make it an addition or subtraction problem. All right, x plus 5. According to the arrow, would this be greater than or less than?
Less than.
Greater than.
The arrow's going to the
Yeah.
right, so it's greater than. It's greater than.
Oh,
Okay, is it going to be the equal to bar? How do you know that? Because it's a closed dot. And, okay, so to solve this, I'm going to need to subtract 5 from some number. What can I subtract 5 from for my answer to be -1? Samuel? 4. So if 4 is on the other side, when I subtract 5 from both sides, what's 4 minus 5?
-1.
X is greater than or equal to -1, which matches my graph up here. Okay? So my answer, when it's graphed, would look like the graph. So here's the actual answer. The answer is the inequality. You actually don't have to solve it. The answer is the inequality. Give me their equation that they use, Jack.
I did x minus 10 is greater than or equal to -11.
Okay? -11. I love it because when he adds 10 to both sides, his answer is -1. Awesome job. Great job. All right. Matthew, what'd you put?
X minus 2 plus 5 is less than equal to 2.
Okay. Very good. Yes, 2. Okay. So what he did was he just made it a little extra complicated there. -2 plus 5 is 3. Then when you subtract 3 from both sides, you still get -1. That's fine. I like the creativity. I appreciate that. Anybody else? Anybody else? Colin?
b minus 8 is greater than or equal to -9.
Love it. Great job, guys. All right, one more. Joel?
W minus 2 is greater than or equal to -3.
Yes, great job. All right, so I think you guys did very well on that. All right, now my last example deals with a modeling real life question. I'll read it out loud. You read it to yourself. To become an astronaut pilot for NASA, a person can be no taller than 6.25 feet. Your friend is 5 feet 9 inches tall. How much can your friend grow and still meet the requirement? So when I'm setting up an inequality, I still want you to start with the final amount, okay? Remember, an inequality is a comparison between two values, okay? So what is kind of like my ultimate value here that I may be comparing?
6.25.
The 6.25, okay? That's my end value. Now I'm comparing it to some combination of the other values. It says my friend is 5 feet 9 inches tall. How can I write that, though, as a value? That's not quite matching up with 6.25. You're on the right track.
5.9.
Okay? It's not 5.9. Think about this. A decimal value represents how much of a whole. So 9 inches. Okay, here we go. 9 inches out of what's my total? 12 inches would reduce to 3/4 or 0.75. Okay, so 5. Does everybody see how we got 5.75? Now, I need to know, actually, I should have written this over here.
Inches.
Okay, X, okay, so X or H, I'll use H. All right, and then 5.75. So how do I know if a plus sign needs to go here or a minus sign?
Plus.
How do you know?
Because it says how much can you grow.
I heard it. Grow. Grow is adding. Grow is positive. So I'm saying he's going to grow. I'm not sure by how much. I know he's already 5.75 feet tall. How does that need to compare to 6.25? It needs to be less than or equal to, because if he's 6.25, he's still okay. Or she. Why do I keep saying he? It could be a she. Could be a female astronaut. Okay? All right. Hey. All right, so now we subtract. We just solve. 5.75. Guys, please stop talking. When I subtract them, h is less than or equal to half a foot. Or how else could I write that answer? That might make a little more sense, or at least sound a little more. I'm hearing it. What's half a foot? 6 inches, right? That makes a little more sense to me. Okay, 6 inches, which means, okay, if this person is 32 years old, do you think that they're going to grow 6 more inches? No. If they're 12, do you think there's a chance? Yeah, okay, so based on, if like they're doing a project or something in school, like I want to be a pilot one day, and they're already 6'5", probably too tall. Okay, did y'all know that there's a height limit? Did you know that? There is. There is a height limit. Yep. It's very specific. Guys, okay, listen, I just need to wrap up the video. Okay, that's everything you need to know for section 4.5.